Imagine this, every single person on Earth, all 8 billion of us, gathered in one place. What if we all decided to jump at the exact same time? Would the planet even notice? Or would we create a cataclysmic event, throwing everything off balance? It's a question that might sound silly at first, but trust me, the science behind it is fascinating. It tells us a lot about the incredible forces at play on our planet. Let's dive in and explore what would happen if everyone jumped at once. First, let's address the logistical elephant in the room. Gathering every single human being in one location is practically impossible. We're talking about finding a space large enough to fit roughly twice the population of China. Even if we could overcome the geographical hurdles, there's the issue of timing. We'd need everyone synchronized down to the millisecond. For the sake of our thought experiment, let's assume we've solved all these logistical nightmares. Everyone has their designated jumping spot, and a universal countdown is underway. The anticipation is palpable. The countdown reaches 0, the world jumps. Now let's assume the average person can jump about 2 feet high. When we jump, we exert a force on the ground. That force is equal to our weight, but in the opposite direction. That's what propels us upwards. Multiply that force by 8 billion people, and we're talking about a massive amount of energy being transferred into the Earth. But where does all that energy go? The Earth's crust, while seemingly solid, is actually somewhat elastic. This elasticity allows it to absorb and transmit energy, much like a rubber band stretching and snapping back into place. When we jump, the energy from our collective leap wouldn't just disappear. Instead, it would be transferred into the ground beneath us. This energy would travel through the Earth's crust as seismic waves, similar to how ripples spread out when a stone is thrown into a pond. These waves would spread out from our giant human epicenter, radiating in all directions. Now, would we cause a catastrophic earthquake? Not quite. The energy we generate is minuscule compared to natural seismic events. You see, the Earth is incredibly massive. Its sheer size and mass dwarf any human activity. Even 8 billion people jumping simultaneously wouldn't generate enough energy to cause significant damage. The Earth's crust is designed to handle much larger forces. To put things in perspective, the energy released by a magnitude 9 earthquake, like the one that struck Japan in 2011, is far greater than the energy generated by our global jump. That earthquake released energy equivalent to hundreds of millions of tons of TNT. We might feel a slight tremor, kind of like a small truck rumbling by. The vibrations would be noticeable but not alarming, but nothing to write home about. Life would go on as usual, with most people barely noticing the event. The Earth's resilience is truly remarkable. Can we throw Earth off balance? This question might seem like something out of a science fiction novel, but it actually touches on some fascinating principles of physics, a moment of planetary spin cycle. Imagine the Earth as a giant spinning top, constantly in motion, maintaining its balance through the laws of physics. Here's another intriguing thought. Could our synchronized jump alter the Earth's rotation? Picture millions of people around the world all jumping at the exact same time. Could this collective action have any significant impact on our planet's spin? It's a question that highlights the concept of angular momentum. Angular momentum is a fundamental principle in physics that helps us understand rotational motion. Angular momentum is a measure of how much an object is rotating. It's determined by the object's mass, the speed at which it's spinning, and how that mass is distributed around the axis of rotation. It depends on the object's mass, how fast it's spinning, and how that mass is distributed. For instance, a figure skater can spin faster by pulling in their arms, reducing the distribution of their mass. Now, Earth is constantly rotating, giving us day and night. This rotation is incredibly stable and has been consistent for billions of years. Our planet is massive and spins at a pretty good clip, about 1,000 miles per hour at the equator. This speed is what gives us the cycle of day and night, and it's a crucial part of life on Earth. While our global jump would technically transfer some angular momentum to the Earth, the effect would be infinitesimally small. The sheer size and mass of the Earth make it incredibly resistant to such minor changes. Think of it like a fly landing on a spinning top. The fly's tiny mass and the minimal force it exerts are negligible compared to the top's overall motion. It might cause a minuscule wobble, but the top will continue to spin as it did before. Similarly, Our synchronized jump would be a mere blip in the grand scheme of Earth's rotation, barely noticeable in the vastness of our planet's dynamics. Escaping Earth's grasp? Not so fast. Okay, let's take this thought experiment to an extreme. Imagine if every single person on Earth jumped at the exact same time. Would that be enough to push our planet out of its orbit? What if, instead of just jumping, we wanted to launch Earth out of its orbit? Could we somehow generate enough force to propel our entire planet away from the sun? Could we generate enough force to break free from the sun's gravitational pull? The sun's gravity is incredibly strong, holding Earth in a delicate balance. The answer, in short, is a resounding no. Even with all our technological advancements, we are nowhere near capable of such a feat. The amount of energy required to achieve that is astronomical. We're talking about energy levels that are beyond our current understanding and capabilities. We're talking about forces on par with supernova explosions, black hole collisions, or the impact that wiped out the dinosaurs. These are events that release unimaginable amounts of energy. The impact that wiped out the dinosaurs was a cataclysmic event, and even that wouldn't be enough to launch Earth out of its orbit. Our collective jump wouldn't even make a dent in the cosmic scheme of things. The forces at play in our solar system are far beyond anything we can influence. So while it's fun to imagine, escaping Earth's grasp is not something we can achieve anytime soon. Earth, the ultimate survivor. Our exploration of this hypothetical scenario reveals a profound truth. Earth is incredibly resilient. Over billions of years, it has withstood countless asteroid impacts, volcanic eruptions, and earthquakes far more powerful than anything we could ever muster. Our planet has a remarkable ability to absorb and redistribute energy. It's a testament to the immense forces that shape our world, forces far greater than the sum of humanity. Reflecting on our insignificant significance. So what can we conclude from our global jumping experiment? On a cosmic scale, our impact might seem insignificant. We are but a small species on a tiny planet in a vast and ancient universe. Yet that doesn't mean our existence is meaningless. We have the power to study, to learn, and to appreciate the wonders of the universe around us. And sometimes it's through asking seemingly silly questions that we uncover the most profound truths about our world. The joy of scientific curiosity. So the next time you find yourself pondering a seemingly absurd what-if scenario, don't dismiss it. Embrace your curiosity. Dive into the science. You never know what amazing discoveries await you. After all, that's how we make sense of the universe and our place within it.